It begins far beyond our atmosphere, in the heart of the solar system, where the sun, a massive sphere of nuclear fire, burns relentlessly. Every second, it fuses hundreds of millions of tons of hydrogen into helium, releasing more energy than our civilization has ever consumed in its entire history. Most of the time, this power gives us life, warming our planet, powering our ecosystems, and defining the very concept of time. But every now and then, the sun reminds us that it's not just a source of light. It's also a cosmic wildcard. Without warning, the sun can unleash a sudden explosion of energy, a solar flare, hurling radiation into space at the speed of light. If conditions are just right, this flare may be accompanied by something far more dangerous, a coronal mass ejection, a titanic burst of solar plasma, traveling at millions of kilometers per hour, aimed squarely at Earth. There's no explosion, no sound, no fiery impact when it reaches us, just a slow, invisible ripple that strikes the magnetic field surrounding our planet. But make no mistake, when it arrives, it can disrupt the very foundations of modern life. The question is not whether such a storm will happen again. It's whether we'll be prepared when it does. To understand the threat, we first need to understand the sun itself, not as a warm, glowing disk in the sky, but as a violently active star. Its surface is not solid, but a boiling sea of superheated gas, plasma, where magnetic fields twist and shift like serpents beneath the waves. These magnetic fields can store colossal amounts of energy, and when they become unstable, when their lines tangle too tightly and suddenly snap, all that energy is released in a flash, a solar flare. A solar flare is not a physical explosion in the way we imagine. It's a blast of electromagnetic radiation, including X-rays and ultraviolet light. That radiation spreads outward at light speed, reaching Earth in just over 8 minutes. On its own, this radiation can disrupt radio communications and affect the upper atmosphere. But it's the events that often follow a flare, the slower, heavier surge of charged particles, that pose the greatest danger. This is the coronal mass ejection, or CME, a billion-ton cloud of plasma ripped from the sun's corona and hurled across space. It travels slower than the radiation, but with far more destructive potential. And if it's headed toward Earth, it becomes a race against time. Earth is not defenseless. Our planet is wrapped in a magnetic shield, the magnetosphere, created by the churning of molten iron deep within the Earth's core. This magnetic field acts as a barrier, deflecting most of the solar wind and protecting our atmosphere from being stripped away, as happened to Mars long ago. But when a powerful CME collides with this shield, it doesn't simply bounce off. It disturbs the field, bends it, and sometimes tears it open. The resulting interaction, a geomagnetic storm, sends waves of current surging through the upper atmosphere and down into the ground. These currents, in turn, infiltrate our infrastructure. Long power lines act like antennas, drawing in the geomagnetic energy. Transformers, the heavy machines that regulate high-voltage electricity, are particularly vulnerable. They can overheat, malfunction, or be destroyed outright. During a severe geomagnetic storm, power grids can fail in minutes. Satellites can lose control or be disabled entirely. High-frequency radio communications, like those used by ships and aircraft, can vanish without warning. GPS signals can be scrambled. Pipelines can corrode at accelerated rates. The storm may be invisible to the eye, save for dazzling auroras lighting up skies far from the poles, but its effects ripple through every modern system we rely on. This may sound like a doomsday scenario, but it's already happened. In 1859, A solar storm struck Earth with such intensity that the auroras were seen as far south as the Caribbean. Telegraph systems, the cutting-edge technology of the time, sparked with fire. Operators reported receiving electric shocks, paper caught flame, and messages were sent even with batteries disconnected. This was the Carrington event, the largest geomagnetic storm ever recorded. It's important to remember, in 1859, electricity played a minimal role in daily life. There were no satellites, no power grids, no internet, no aircraft. And yet the disruption was profound. If a storm of that magnitude hit today, it would affect nearly every aspect of modern civilization. Studies suggest that if a Carrington-class event struck now, it could cause trillions of dollars in damage. Entire power grids could go down across continents. Communication networks could be crippled. Stock markets might freeze. Emergency response systems would be strained to their limits. And all of it triggered by a ripple of energy from a star 150 million kilometers away. And here's the most unsettling part. We almost lived through this in our own time. In July of 2012, the Sun released a massive CME, one comparable in strength to the Carrington event. The eruption was fast, violent, and powerful enough to cause global-scale damage. But by sheer coincidence, Earth was not in its path. The storm missed us by about 9 days. Had the Sun rotated slightly earlier, had the timing been just a little different, we would have faced one of the most extreme space weather events in human history. Experts from NASA later admitted, had it hit, we would still be picking up the pieces. Our satellites might be dark, power grids damaged beyond quick repair, supply chains paralyzed. Recovery could have taken months or even longer, but that near miss faded quietly from the headlines. There was no global mobilization, no massive infrastructure overhaul, no urgent political action. Just another bullet dodged and forgotten. In some ways, we are more prepared than ever. We have satellites monitoring the Sun in real time, operated by NASA, NOAA, and space agencies around the world. Space weather forecasts give us early warning, hours, sometimes even days, before a CME arrives. Communication systems can be temporarily shut down. Flights can be rerouted. Critical systems can be put into safe modes. But awareness is not the same as resilience. The reality is, most of the global power grid, particularly in developed nations, is not built to withstand a large geomagnetic storm. High-voltage transformers are delicate, expensive, and extremely difficult to replace. There are very few spares. Some countries outsource their manufacturing, which introduces long delays. And once a transformer is destroyed, replacing it is not a matter of flipping a switch, it's a matter of months. Worse still, many nations do not have solar storm contingency plans. There are no drills, no civil preparedness campaigns, no dedicated emergency protocols at the scale this threat requires. Despite the science being clear, despite the data, the warnings, the near misses, we are, in many ways, unprepared. The good news? There are solutions. We can build resilience into our infrastructure by installing surge protectors on transformers, redesigning grid layouts to isolate damage, and creating stockpiles of replacement parts. We can develop better forecasting models and global alert systems, ensuring that every country has the information they need to act fast. Military and aviation industries already take space weather seriously. Many satellites and aircraft can be placed in safe modes, delaying launches or rerouting flights. But this needs to extend to the civilian world, where lives and livelihoods are just as vulnerable. Above all, we need to treat solar storms with the same urgency we give to other natural disasters. Not because they happen often, but because when they do, the consequences are catastrophic. The sun has been burning for over 4.5 billion years. It will burn for billions more. But for all its beauty and life-giving warmth, it is still a force of nature we barely understand and cannot control. Somewhere in the future, maybe decades away, maybe tomorrow, another great flare will erupt. A CME will leave the sun, and once again, we'll watch and wait to see if it's coming for us. There will be no explosion, no countdown, no sirens. Just a ripple through space, and the hope that we're ready. Because the sun doesn't care about our grids. It doesn't care about our satellites, our smartphones, or our cities. It simply burns. And every once in a while, it reminds us who's really in charge.